In this lesson, for indices and surds, we are going to look at rationalising surds again. So to start with, we need to define that a binomial expression is an expression that contains two terms. So here's one term, here's a second term. This makes this a binomial expression. Secondly, we need to just define that in algebra, a conjugate is a binomial formed by negating the second term of a binomial. For example, if we have the term x plus y, then x minus y makes its conjugate pair, since the y is negated from one term to another. Also, minus x minus y and minus x plus y are conjugate pairs, again because the minus y and plus y are negated. We could equally have x plus y and minus x plus y. Generally speaking, it is this form here that we tend to focus on, and you will be familiar with this from the difference of two squares. And that leads us into rationalising binomial denominators, because to rationalise a fraction with a binomial denominator containing a surd, the properties of the difference of two squares are required. So it's using this here. Here we have our conjugate pairs. Okay, and using our conjugate pair, multiply them together, we notice that we only get the squared terms. So if we then apply this to expressions using surds, then what we get, notice in this conjugate pair, we get 8 plus root b plus times by a minus root b gives us a squared minus b. The surd term is removed. Similarly, if I have root a plus root b times root a minus root b, then I get a minus b, and it's removed the surds again. And these properties can be used to rationalise expressions, and so we can use this to rationalise binomial denominators. Okay, so we have three examples here. Rationalise and simplify these three expressions. So starting with 8 over 3 minus root 5. What we want to do is we want to multiply the top and bottom of this expression by the conjugate. Please remember that this is implied in brackets underneath here, so write your expressions in brackets as well. The conjugate is exactly the same expression, but notice I've swapped the sign here from plus to minus. And I'm just going to multiply top and bottom by 3 plus root 5. So what we get, 8 times 3 is 24. 8 times root 5 is 8 root 5. Now what I'm going to do is I'm just going to write it down. I'm going to remind you the properties of the difference of two squares, because really we don't need to write the full expansion here. What we have to do is just use this property, and it'll help you become familiar with it and use it more frequently. So just take care, I get 3 squared minus root 5 squared, and it's good practice to write it out like this to get used to it and make sure we don't make any silly mistakes. Quite often a common mistake here is to square the root 5 and write 25. We must not do that. So I get 24 plus 8 root 5 over 9, and so that's 3 squared, and then root 5 squared gives us 5. Now I'm going to get 4 on the denominator here, so it looks likely I can cancel. So what I'm going to do is I'm just going to factorise the numerator, and it looks like perhaps I shouldn't have bothered expanding, but we can never always tell. It's just in this case I shouldn't perhaps have bothered expanding. So I get 8 times 3 plus root 5 over 4. If I divide top and bottom by 4, we get left with 2 times 3 plus root 5. And just leaving it like this is completely acceptable. Okay, let's have a look at the second example. Second example, I've got 7 over 4 root 2 plus 5. So again, what I'm going to do is I'm going to multiply by the conjugates here. So I'm going to multiply the top, and remember, again, if you need to, put this in brackets, remind yourself, this is 4 root 2 minus 5 times 4 root 2 minus 5. Okay, in the numerator, I get 28 root 2 minus 35. So I've multiplied 7 by 4 root 2 and 7 times minus 5. On the denominator, using the properties of squares, so I'm going to get 4 root 2 squared minus 5 squared. Start to simplify. There's nothing really to do on the numerator at the moment. So I get 28 root 2 minus 35 over, on the denominator, 4 squared is 16, and then root 2 squared is 2. Do it in 2 steps, do the 2 parts separately, remember to square the 4 and the root 2. It's much better to take an extra step in working than making any silly mistakes. So I get 16 root 2 minus 25. And in fact, if I notice on here, I'm going to get 32 minus 25, so it's going to get 7. And again, I know I've got 7 as a common factor here, so I'm going to factorise it back again. So I get 4 root 2. And it just so happens, not every example does this, but just so happens in this example, I didn't necessarily need to expand for the numerator, but other examples you do. So it's always better to do it and then look for the factors afterwards. Now you can see I've got this common factor of 7 in the numerator and denominator, so I just get left with dividing through top and bottom by 7, we get 4 root 2 minus 5. Okay, so let's look at the third and final example then. This example looks a lot more complicated, but actually the process is exactly the same. Okay, here's my denominator. I want to multiply by the conjugate of that denominator. So remembering that this is in brackets, and in fact the top we want to consider is in brackets as well. I'm going to multiply it by root 3 minus root 6, both top and bottom. Okay, in the numerator, I get 2 root 3 times root 3, so I get 2 root 3 squared. 2 root 3 times minus root 6 will give me minus 2 root 18. Root 6 times root 3 will give me plus root 18. And then root 6 times minus root 6 gives me minus root 6 squared. All over. Using the difference of 2 squares, we're going to get root 3 times root 3, so we're going to get the root 3 squared. Take away the root 6 times root 6, which is root 6. So squared and squared. Tidying up, I have 2 times 3. I've got minus root 18, because I've got minus 2 plus 1, and then minus 6. And this is all over 3 minus 6. So then just finishing off, tidying up now, I get 6 minus 6 is 0. So I get left with root 18. On the denominator, I get over minus 3. Now, you may be tempted to think that we're complete here, but notice that root 18 has a square factor, and in fact I can write this as root 9 times root 2 over minus 3, which is then 3 root 2 over minus 3. And so dividing top and bottom by 3, I just get left with minus root 2. Okay, I hope they all made sense and that you was able to follow my solutions there.